we look at repeated linear factor. Repeated linear factor. That is denominator with a linear with a repeated denominator with a repeated factor. Alright. For instance, you have a raised to the power 3. How many powers can we get out of a raised to the power 3? You can get a raised to the power 1 times a raised to the power 2 and a raised to the power 3 itself. So now you can see that the power or the power 3 is repeating itself again. So that is a denominator with a repeated factor. So this a can be s plus 1. So with this you get s plus 1 to the power 1, s plus 1 to the power 2, s plus 1 to the power 3. Then it continues like that. It depends on the power that we have here. Very good. So, when such case happens, for instance, you have f of x over a case where we have, let's say, ax plus b power 3. This is going to be identical to, you see, it's a denominator with a repeated factor. Alright? But the repeated factor will just be applying here. Here we get ax plus b power 1, ax plus b power 2, ax plus b power 3. But what will come on the numerator here depends whether the inside here is linear or quadratic. I hope it's clear. I hope it's clear. Alright. So this is linear, and since it's linear, it will be A, B, C. Thank you. But there can be a case there can be a case that the inside here is going to be a quadratic. So if here is square, it's a quadratic. The idea of the repeated factor is what is applied on the denominator. So the numerator will depend on what is here. So this will be ax plus b. This will be cx plus d. Then ex plus f. That is how that is also going to be. Very good. Very good. Now, what if the denominator is just x? It's just x squared. Does it mean it's quadratic? Oh, no, it doesn't mean it's quadratic. The fact that it's just x squared doesn't mean it's quadratic. It can be written as this: x plus or minus 0 all squared. It's still the same as x squared, and this is a repeated factor. Don't forget that it's a repeated factor. So this is going to be identical to a over x plus 0. So now we know that this is the same as x squared, and it's a repeated factor. So you're going to get x power 1 and x power 2. And since the inside here is linear, here will be a. Since the inside here is linear, here will be b. I hope it's clear. Don't confuse yourself with that, because normally people get themselves confused. So when you give them something like x squared ax plus b, they start confusing themselves, thinking this is quadratic. So they say ax plus b over x squared. This is wrong. But rather treat this as a repeated factor. So The inside is linear, A, B. Then plus this is linear, and this is a repeated factor. So you make it C over AS plus B plus D over AS. That is all. Alright, so that is the linear part and the repeated part. I hope I have made myself clear. Very good. So let's try on our first question. Integral of okay. So having this to do, you can see that this the denominator is a repeated factor. In fact, first check if it's use substitution will help or not help. Alright? Because watch. Use substitution. Yeah, you can see. Because when we set u to be equal to the inside, we are going to get 3d u to be equal to 3s squared. And when you do the substitution, you can clear off. So always check the powers here. Alright? Very good. Now, we know that our first thing to check when giving such question like this is to check whether the degree of the numerator is less to the denominator so that we can decompose by partial fractions. So with this, and as you can see, is it that? What is the power of the numerator? 1. Very good. What is the power of the denominator? It's not 1. To see it clearly, you have to expand and simplify this. And you can see that definitely you are going to get it higher degree to 3 because of the quantity. If it's 1, 2, the higher degree will be 2. Depend on what will be there. So the power of the numerator is less than that of the denominator. So you can now express. So this will be plus 3 times because here power 1, power 2, power 3, and s minus 2, s minus 2, s minus 2. So this is linear. This is linear. This is, I want to see how to take my time to explain to you. So when you are done with that, the next thing to do is the else here. And that's exactly what is here. So the A will multiply s minus 2 squared because this takes one of this. Plus the B will just multiply. You see, it has taken twice of this. So s minus 2 plus C will multiply just like that. Because this will cancel this. So we equate the numerator, which is s. Forget about the calculus. Forget about the calculus. In fact, I should have first bring out the function before expressing. Forgive me, alright? Just do that for me, do that for me. Or I can now bring this. because to integrate this is same as integrating this. It's now correct. But for me to bring the integral sign here as referred to ds without bringing it here, it's wrong. Alright? Okay. So now we are just basing on the function. Okay, what are we going to do now? When you put s to be equal to 2, do that. Here will be 0, 0. So we get 2 is equal to c, so c is equal to 2. Then we go by putting s to be equal to 0. And when you put s to be equal to 0, you see, watch. Here is 0, you get negative 2, here is 0, you get negative 2. So you are not going to eliminate anything. It's just going to be, the equation is going to be in the A, B, C back again, which is not going to add any value to what you're going to do. So at the end, you end up by expanding and simplifying the right hand side. So let's do that and go our way. So when you expand and simplify, you are going to get it in the form. Make sure you can pause the video and do that. Expand and simplify this and see what you are going to get. Alright? Very good. So you are going to get it. So therefore, comparing the corresponding terms, we are going to get the coefficient of s cubed is not here. So a is 0. For s square also, it's going to be negative 6. A is equal to 0 because there is no coefficient of s square here. So that is 0. And when you equate, a is 0. Oh, you can see, no need to have to go for coefficient of s squared because that's the same as what we have found here and it's 0. So let's move to the next one. 12a plus b. The coefficient of s here is 1. And we know a is 0. So 12 0 plus b is equal to 1. So b is 1. Hope you can see that. Then we go for c. The constant is negative 2b minus c, or plus c, which is equal to, the constant here is 0. But we know b is 1. Negative 2 plus c is equal to 0. So c is equal to 2. So now we get our c to be equal to 2. So a is 0, b is 1, and c is 2. So the only thing left is to come back and do the substitution. A is 0. Ooh, wow. I like 0. I like 0. That's the reason why I like 0. No matter what is in the denominator, everything is 0. I like 0. C is 2, O. B is 1. This everything I'm doing on the board, you can't do that, so you have to rewrite it back. C is 2. In your book, you can't do that. So here, everything here is 0. Yes, 2 out, 1 over. Yes. So now you can see, everything now is simple. You are left to integrate this, and that is all. And how do we integrate that? I would like to do that here. So you set u to be equal to s minus 2. The u is equal to what? Dx. So here you add 1 to the power, you divide by it. So when you add 1, you get negative 1. Divide by it, you get negative. So you're going to get 1 over u. And this is negative 1 over s minus 2. Then you go for this. In fact, looking at what this is, you can tell what this is. But let's see. Two is multiplying, don't forget that. Add 1 to the power, and with that you are going to get 2 u raised to the power negative 2. Then you divide by the negative 2. So you are going to get negative u squared negative 2. And this is going to be negative 1 over u squared. Alright. So that's why I'm saying that by looking at what this is, you can tell what this will be. So you see here the power was 2. And now you end up by getting the power to be 1. Here the power is 3. So you end up by getting the power to be. So just by the way, our final answer is going to be negative 1 over s minus 2 squared. Alright. So please, this resolve to this. This resolve to this. Finally, we end up by getting negative 1 s minus 2 plus negative 1 over s minus 2 squared plus c. So that becomes our final answer for that. Very good. So that is the one dealing with the repeated factor. I would like to add one more question to it, but I'm tired. I will try. Let's see. Alright, let's look at this question. You see, when the question is given to you, alright, you have to investigate. First of all, what is the degree of the numerator? 3. What is the degree of the denominator? Please don't tell me 1, don't tell me 2. No, you have 1 here to 1, you have 2 here to 2. No. It's unless this is a factorized form. So it's unless you expand and simplify so that you can tell me the higher degree. So with this, simply multiply this by this gives power 3. And this will affect it. So everything here, when you simplify it, you are going to get that to be of power 5. Alright. So now, let's see. We are going to write this out. So here we bring the function out. So we get plus 3x plus 2 over only the function that we are bringing out. This one is already factorized, so you don't need to worry yourself. So this is going to be identical to. Now, the first one we have here is linear. So here is A. It's a power 1, so it's linear. It's not a repeated factor. If it's power 2 or more, that becomes a repeated factor. Here we get x squared plus 1. It's a repeated factor because it's having a power of 2. So this is power 1 plus x squared plus 1 squared. Now, here, what is coming here depends on what is here. So what is this? Quadratic. ds plus c. What is this? Still quadratic. ds plus e. So that is what this is going to do. You can pause the video and complete everything and come back again. So you find the LCM, and the LCM is going to give you exactly what is here, which is s squared plus 1 whole squared. Alright, so the A is going to multiply s squared plus 1 squared plus bs plus c is going to multiply s, then s squared plus 1 plus dx plus e. This is just going to multiply x. Very good. Now you know where we are going. That is equating the numerators. So x cubed minus 2x squared plus. Now this s, you can bring it here. Very good. So that is what we have here. Now, here, let's expand and simplify the right hand side and start comparing coefficients. So you can pause the video and be doing that on your own. Expand and simplify, and let's compare coefficients. So when you do that, you are going to get. So for this, you are going to get x raised to the power 4, and the coefficient is a plus b plus x raised to the power 3, and the coefficient is c plus x raised to the power 2, and the coefficient is 2a plus b, 2a plus b plus d plus the constant, which is going to be c plus e, c plus e plus a. That is the constant that we are going to get. So when you compare the coefficients, then you compare the coefficients, you can see clearly that for this, you can see clearly that here we can choose to do this. You can choose to do this. First of all, with this side, before you expand and simplify the right hand side, you can set x to be equal to 0. Now watch. Before you come to expand and simplify to get this, that's what I'm talking about. You can expand and simplify the right hand side. Sorry. you can set S to be equal to 0. For S to be equal to 0, the B here will vanish. In fact, since S is here, everything here will be 0. And since S is here, everything here will be 0. So when you put, before you come to this, S will be equal to 0. 0, 0, 0, 0, here will be 2 is equal to, you know that here will be 0, here will be 0, so we get A, 0 square plus 1 whole square. So 2 is equal to A. How we can see that we can get 2 to be equal to A. Very good. So now after setting S to be equal to 0, that is the elimination. You are not going here, you can't get anything again to substitute it to get rid of any of the variables. None of it, not even negative 1. Because negative 1 here, it will be undo because of the square. So the only thing that you can do now is to expand and simplify it. And I don't take it to that process. You can do it on your own. So you're going to get this very good. So now when you compare coefficients, you can see that here is 0s to the power 4 plus s to the power 3 minus 2s squared plus 3s plus 2. The coefficient of s to the power 4 here is a plus b. And the coefficient of s to the power 4 here is 0, so equation 1. Now you know a, so you cannot b, so b is equal to negative 2. Hope it's clear. Alright. S to the power 3 here is c. S to the power 3 here is 1. That means that c is equal to 1. Here, s squared. Here we have 2a plus b plus d. S squared, and the coefficient here is negative 2. Here, negative 2. But we know A, B, and C. So by substitution, A is 2. B is negative 2 plus D is equal to negative 2. Now watch. We get 4 minus 2 plus D is equal to negative 2. When you set this one here, these two will cancel. So D is equal to negative 4. So we get D also to be equal to negative 4. Now what is left? That is E. But the E is not anything difficult. We have E here, right? So C plus E plus A is equal to the coefficient here, which is 2. But we know C, 1. We don't know E. We know A, 2. Now, we can see that E will be equal to I want to check something. C plus E. Oh, sorry. Sorry. Here will be coefficient of S, C plus E. Here, plus A. When you expand and simplify, this is what you are supposed to get. Very good. You had it. Very good. So now, the E is going to be C plus E is equal to the coefficient of S here, which is 3. C is 1 plus E is equal to 3. So E will be equal to 2. How we can see that? Very good. Then, as usual, you come back. Please, I would like to bring this back, so make sure you put the video right. Then you come back. You do the substitution. A is 2. B is negative 2s plus C is 1 over s squared plus 1 plus D is negative 4s plus E 2 over s squared plus 1 squared. Very good. Very good. Now please be careful. Don't be applying hot negative here. Because this is affecting only this, not this. So when you bring it here, you are wrong. You cannot say this is the same as this. Never, never. But you can rewrite this as 1 minus 2s. And you can rewrite this as 2 minus 4s. Be careful, alright? Be careful. You can do this. Now, to integrate this as respect to s, it's the same as integrating this as respect to s. So you integrate this, you get 2 ln s plus, to integrate this, to integrate minus 2s plus 1 over s squared plus 1. You come back to it, ds, plus, here you can factorize the constant out. 2 integral of 1 minus 2x over s squared plus 1 squared ds. Now we move on. We are left to integrate this and this and go about it. Good. So now we know that this will be 2 ln s. But let's go for this. Here we can split it, alright? We can split this. Negative 2s over s squared plus 1 ds plus integral of 1 over s squared plus 1 ds. We can split it, alright? And when we split it, this is just going to be u substitution. Then this is just tan inverse. Very good. So here, this is u is equal to s squared plus 1. Du is equal to 2s dx. So integral of negative 2s over u times dx there is du over 2s. 2s cancel 2s. So you get negative ln u, which is negative ln s squared plus 1. Now, what we have here is just tan inverse of x, because the one here is like 1 square, a square. So s over 1, 1. 1 over 1, 1. So that is tan inverse. So we are able to establish that part. Let's go for, so we have established this part, that is going to be therefore, please, therefore, this implies that we are going to get negatively s squared plus 1 plus tan inverse of s. That is for this. Let's go for this. In the same way, we split. In fact, the technique of splitting is what is embedded in, or is what we are applying here. So please take note of it very well. With this, we can split it. Let me finish that. So we have integral 1 minus 2s over s squared plus 1 squared dx. So this one, we can write it as so here we solve a similar one, and I don't know if you have forgotten it. Now with this, you can see that U substitution will not work. U substitution will not work for this. But we can still solve it with our idea of trigonometric substitution. With our idea with trigonometric substitution, we know that this is U substitution. This one, there's no problem about it. But with this one, so I need a space. Let me go here. Oh, I've cleaned that part. Now, integral of 1 over s squared plus 1. This is the same as we can bring this here. Now, this is positive, right? So we bring square root of s squared plus 1. Then you know that here is going to be the s, here is going to be the 1. Very good. So here we get tan theta to become to x over 1. Then we differentiate. We get sec square theta. Sec square theta to be equal to sec square theta d theta to be equal to ds. So we know that ds is the same as sec square theta d theta, and we know that x is equal to this. So by substitution, we get, by substitution, you are going to get tan theta squared plus 1 all squared. ds is sec square theta d theta. So we get 1 over tan square theta plus 1 all squared sec square theta d theta. Now 1 over the inside here is sec squared. This cancel this, we get it to log 1 theta, which is theta. We have left something out. Here, the power 2. What we get in the power 2? So here is 1 over sec square, because you're going to get power 4, so it will clear one of these, so that is that. And integral of 1 over sec square theta is the same as integral of cos square theta theta. And integral of cos square theta is going to be replaced by half angle, because the power there is what? Even. So we are going to replace that by half angle. I need space. And when we replace that by half angle, we are going to get integral of half 1 minus cos 2 theta cos 2 theta d theta, or yeah, something like that. That's it. So that is that for that. This is cos square theta. Oh, so here will be plus. Very good. So now this is half plus half cos 2 theta d theta. Then you integrate it 10 by 10. You integrate it 10 by 10. Alright. So you know when you integrate this, you get half theta plus, you integrate this, we get sine 2 theta over 4. You know the technique. The 2 here will multiply this, you get 4 here. Very good. So that is what you are going to get. That is what you are going to get. Alright. But we know that theta is equal to what? We transform back. Theta will be equal to tan inverse. I need space. Okay, for now I can clean this. Theta is equal to, if S is equal to tan theta, then theta will be equal to tan inverse of S. So we have established that. We have established that. And we know that sine sine 2 theta is equal to 2 sine theta cos theta. So from a diagram, what is sine theta? Sine theta is going to be S over R. That is opposite over adjacent. Then cos theta is going to be adjacent over the hypotenuse. Alright? Very good. So we are going to get that to be half tan inverse of S plus S over square root of S squared plus 1 plus the expression of only the numerator here is this and this, don't forget. 1 over S squared plus 4. All these over 4. That is what we have. So you can now bring everything together. You can now bring everything together. Alright. And you can see perfectly that this, we have already done this. Bring that, then plus 2 multiplying the whole of this part. Because this is the result for this. So 2 will multiply everything of that part. Then you add it to plus C. So that is that for that. Make sure, in case you don't understand anything, play by the video, play it, and you will understand it. Alright? Very good. And now, it may be that you are doubting, why is it that I'm applying trig substitution here? It doesn't affect anything. Because here we can rewrite this as 1 over we can rewrite this as this. We bring the square root, then we undo it. So we go and apply only that on that, so that we get square root inside of it to transform it to Pythagoras. It doesn't cost anything. It's still the same thing. Alright, so I'll be back for us to look at the last part, which is the case 4, improper. Alright, welcome back. This is improper fractions. Improper fractions. Now, with the improper fractions, we have already talked about it, how to identify it and everything. Alright. We're saying that if the power of the degree or the power of the numerator is greater than the one in the denominator, that means that you can't solve it with a partial fraction decomposition unless you will do long division. So looking at, or the first thing to do for the question right here is that first of all, you need to identify whether it is proper or improper. So looking at it, you can see that the power of the numerator or the degree of the numerator is greater than the one at the denominator. So this means that this is improper. So we have to go for the long division. Alright. So how do we do the long division? You know it already, but let's. This is the dividend, this is the divisor. So we bring this out. We know that this is identical to the quotient plus the remainder over the divisor. So we go for our long division. The divisor, s squared plus s. Here, the one that we can bring 0. You know this already. When this divide by this, you get s. Multiply this by this, you get s. Multiply this by this, you get plus s squared. Then you subtract. This is 0. This is negative s squared. Then you bring the rest of this, which is plus 0 plus 1. Divide. Now multiply the negative 1 by this. You get negative s squared. Multiply this by this, you get negative s. Alright, that's it. Subtract 0. You get s plus 1. So that means that now you can see this can be divided by this. When this divides this, when this divisor, sorry, the quotient, the remainder, or what you say, when you divide by this, you get a proper fraction. So because of that, then you end it. See, when what you have here divide by this, the reason why we go again is that when x minus x squared plus 1 divided by this, the power of the numerator will be the same as the one in the denominator. So that makes it what? An improper fraction. So we go again by dividing, and now we can see that the quotient plus the remainder over the divisor, this part is going to be a proper fraction. So now the quotient is f minus 1 plus the remainder f plus 1 over the divisor f squared plus s. So now we can now solve it. Alright. Here, to integrate this as respect to dx, is the same as integrating this as respect to dx. But look at something here. With what we have here is improper. You see, to integrate is no problem, but to integrate s plus 1, s squared plus s dx, it's going to be somehow complex. Even if you know how to split it. Let's try and see. Whether you like it or not, you will still apply your idea under the improper, under the proper. You will still apply the idea of the proper. Oh, you can do use substitution to get, even use substitution here. It will not help, but with this, you can do this. S out, S plus 1. This will cancel this, 1 over this. So if you figure out this, you can get it already. But with this, what can you do? Unless you go and do what? Improper, partial fraction. Because let's express this to partial fraction. Because this you have here is the integral of 1 over s plus 1 dx. This linear, then you go by that idea. With that, you can solve it. Apart from that, you get it. Use substitution will not really help you. Rather integration by parts. I will project the technique to you very well. That it doesn't matter if after explaining the improper, after dividing, and you write it in the form of quotient plus remainder over the divisor. If this is integrable, what I mean is that if only when you integrate this, you will not face any problem. You can choose not to go and express the remainder over the divisor as partial fraction. You can do and go your way. Like this, we can see that here, this is just coming, this is not even turning, this is just ln s plus 1. 1 over, because when you factor s out, this is 1 over s plus 1. So this is ln s plus 1. But with this, you will still do partial fraction. So then why don't we take the whole of this and do the fraction, partial fraction? So let's forget the idea of going by this. I'm not saying it will not work, it will work. But if we are to apply partial fraction here, then why don't we pick this one and do that? But there are sometimes that integration that will be easy for you, that you don't need to go and express it in partial fraction again. So s plus 1 over s squared. Now let's factor. Identical to a over s plus b over s plus 1. So s plus 1 will be identical to a will multiply s plus 1 plus b will multiply s. When you put s to be equal to 0, then we get 1, 0 plus 1 is equal to a 0, so 0 plus 1. Here is 0, so b will go. So we get a to be equal to 1. Because 1 multiply a, we get the same, so we get a to be equal to 1. Now, we know that a is equal to 1. So let's put f to be equal to negative 1. So that here the a will go. So negative 1 plus 1 is equal to b, negative 1. So you get 0 is equal to negative b. So b is equal to 0. B is equal to 0. So a is 1, but b is equal to 0. Alright. Very good. So let's move on. So by substitution. Oh, I would like to clean this part. Okay. So by substitution, a is 1, b is 0. So a is 1, b is 0. Nice. Everything is 0. So to integrate is the same as integrating this. So we get ln x. So this means that here the integral of the whole of this is the ln x. So when we integrate now, we are combining. This implies that When you integrate this, you get s squared over 2 minus s plus the integral of this, which is this, ln s. Very good. So let me see if I can get any example. Another example again. All right. Take one is here. Let's look at our last example here. In fact, I have taught you a lot, so you should be able to pause the video and solve it on your own. So with this, the first thing to do is to go and you know this is improper, straightforward. S to the power 4 minus 3s squared minus 3s minus 2. Alright? The power of the 3 is not there, so you can bring 0 s to the power 3. The dividend is this. In fact, pause the video and continue with it. So that is just algebra. That's just algebra. So after the algebra, quotient, remainder, divisor. So improper fraction is equal to that. So now we are going to integrate this as respect to s. So integrate s plus 1 as respect to s plus integral of s minus 2 s equals 3 minus s squared minus 2s dx. Alright. To integrate this is going to be easy. This is just s squared over 2 plus 1. Is that also plus? But with this part, we have to go by partial fraction because this is now proper fraction. So if it's proper fraction, we can now decompose it to partial fraction. Alright. So we bring out only s minus 2 over s to the power 3 minus s squared minus 2s. Alright, so this is going to be an instance. Don't forget that we have to factorize the denominator. S to the power 3 minus s squared minus 2s. Here we can bring s out. You get s squared minus s minus 2. And when you factorize this, you get s. Alright, so when we factorize that, we get s minus 2, then the other factor will be s plus 1. So this we have here is the same as s minus 2, s plus 1. So this is linear. All right, that is that. Please, we have done all these things before. So go forward to find it. I'm coming out with a final answer. The A is going to be equal to -1. It's the same process that you are going to go through. The B will be equal to 2/3. You can pause the video and solve it on your own. The C is going to be 1/3. C is going to be equal to 1/3. Alright. So by substitution, our A is -1. Our B is 2. So 2 come here, then the 0 come here. Then our C will be 1. Alright. So don't forget that the integral of this is this. So we are now doing this. So to integrate this or this is the same as integrating this. So you now come and combine all the ideas. Integral of -1/x plus dx plus the integral of 2/3 come out 1/x minus 2 dx plus integral of 1/3 1/x plus 1 dx. So you can see this is negative ln x plus 2/3 ln x minus 2 plus 1/3 ln x plus 1. So to combine everything, the result for this is this. Alright, in fact, we can even reduce this. We can reduce that, but you can do that on your own. So we just bring this. So finally we bring x squared over 2. Please make sure you write it well and bring it in order. Plus minus ln x plus 2/3 ln x minus 2 plus 1/3 ln x plus 1 plus c. So that becomes your final answer for that. It's not difficult. I encourage you to keep on solving more questions. And you will have it. Alright, so with all that we are done, I would like you to try your hands on Alright, so you can try your hands on this. See you in our next video. In the next video, I'm going to project to you well about the method of splitting the denominator, or let me say splitting the numerator. I'm going to show it to you well. See you in that. Alright, let me top it up in this same video for you. In fact, I have been introduced to you already about it. That's why I want to add to this video. Okay. So the splitting of the numerator is very, very, very important as far as our course or our techniques under trigonometric integration is concerned. For instance, if you have integral of 1 plus s over 1 plus s squared. If you want to integrate this, you need to split it. Okay, you need to split it. In fact, the another idea you can use to solve this is the improper. Is the partial fraction. You can apply that also. You can apply that because this is going to be a quadratic for you. Alright, but you can just split and go your way. because here is 1 over s squared plus 1 dx plus integral of s over 1 plus 4 s squared plus 1 dx. It's the same thing. This is just tan inverse, and this is just going to be a u substitution where you set u to be equal to this. So that's the idea of the splitting. The splitting of the numerator is just saying that 1 plus s over 1 plus s squared is the same as 1 over 1 plus s squared plus s over 1 plus s squared. And when you apply the integration, you go your way. So you see how simple it is. Very good. Also, we can get something to like this. We can also get something like, hey, where is this? Okay. We can also get something like s minus 1 squared over s squared plus 1 all squared. Very good. Now with this, we know that we are not going to end by solving it, just showing you how to appreciate the idea of splitting the numerator. We know that this is going to be this, we are going to get s squared minus 2s plus 1. Alright, all this over s squared plus 1 all squared. Very good. Here, we can actually split the numerator. In what way? You watch. Watch and see how we are going to split the numerator. When you expand and simplify this, you get this. Now, we can write this as s squared plus 1 minus 2. Hope you can see the same thing. All this over s squared plus 1 all squared, which is the same as s squared plus 1 s squared plus 1 all squared minus 2 over s squared plus 1 all squared. It's the same thing. They are the same thing. If they are sharing the same denominator, then we are going to get the same thing. I hope you can see that. Because we have s squared plus 1 here. Then you can write s squared plus 1. That's why I shift this to this part so that you can see clearly what I want to present to you. Very good. Alright. So with this, you can see that this will cancel one of these. So we get 1 over s squared plus 1 minus 2 over s squared plus 1 all squared. And when you integrate both sides, you go your way. How do you see that this is standing inverse? And with this, you can use trig substitution. Alright? You can use trig substitution here to solve this. And you see how beautiful and nice that is going to be. So it's not that difficult. Oh, sorry. Here is rather x. 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 Beautiful. Beautiful. I forgot to bring it. Sorry. So that is that. That is that. Then that means I'm not going to apply any trig substitution. Since x is here, use substitution. Bam, you go your way. So you can choose not to do this by partial fraction decomposition. You can apply your idea about splitting it, and finally you can get it. This is time inverse, and this is use substitution. Alright. So that is how that works under the idea or the technique for splitting the numerator. Alright. There's one more here I want to add. Oh yes. When you have to integrate u over 1 plus u du, it doesn't matter, you can be s, and here will be s. How do you do that? Technique! Here, this is going to be the same as u. Now you can see this is 1 plus u. We can write it as, okay, don't forget, don't worry. But you know that we can write this as u plus 1. Then I will add 1 here so that I will get the same here. But I have to undo it, du. I haven't done anything to it, it's still the same thing. I create, I destroy. So I will get u plus 1 over u plus 1. What we are doing is algebra, not calculus. Minus 1 over u plus 1. In fact, you need algebra to undo calculus. You need algebra to undo calculus. So you can see that here you can divide it by this, and divide -1 by this. Alright. So this cancel this, so we get integral of 1 minus 1 over u plus 1 du. And with this, we can integrate each term du minus integral of 1 over u plus 1 du. This is just u minus u plus 1. It's not difficult. So this is just in terms of that. You can get it in terms like this. 1 plus s dx. It's still the same thing. Plus 1 minus 1, you go your way. Alright? Very good. So that is how we do such case. And with this, we're going to get u minus u plus 1 plus c. Very good. Is there any more? Anything more? Alright. There is another one that we can, in fact, I want to introduce you to more techniques. With this one, we can split it for it to be simple for us. You see, it seems it's complex, but it's not complex. Let's see. The integral of 1 over 5 minus s square root of this. Quick, you go your way, alright? So with this, you can see that this is just use substitution. But instead you because it is favor, use substitution. But with this, trigonometric substitution. Trigonometric substitution with this. So you can create and destroy it to get. So that you get something like a, and the a is going to be square root of 5. Alright? So you create the square roots. So you're going to be inside of this. So that's that. Very good. That is all. Keep on solving more questions. And until then, bye bye.